All right, this is part 2 of day 10. We're talking about chapter 19 on confidence intervals. And we just talked about the form of a confidence interval. A confidence interval is basically a point estimate, a statistic, plus or minus 2 standard deviations. So a confidence interval is a statistic. The specific statistic we're dealing with is p hat, the proportion. And we're adding and subtracting 2 standard deviations. The 2 standard deviations, the standard deviation is made up of a z-score, so z star, and then our standard error. All right, so our point estimate, plus and minus, our z-score, for depending on whatever size confidence interval we want. And then our standard error of our statistic, which in this case is the square root of p hat, q hat, divided by n. And the reason we use the sample is because that's all we have is a sample. We're giving ourselves a range of plausible values based on our sample. So how do we know if the distribution of p hat is approximately normal? We take n times p, and that has to be greater than 10 or equal to 10. And n times q has to be greater than or equal to 10. And there are other conditions that we have to check. For example, it has to be a random sample and less than 10%. So we're now going to look at our first confidence interval example. So suppose that in a random sample of 200 East High, we'll make it EHS teens, had 18 had tattoos. So our p hat is 18 over 200. So 18 over 200, 0.09. So our point estimate, this is our statistic. Another word for the statistic, they call it a point estimate. It's a single estimate of the number of teens, the proportion of teens that have tattoos. So this is our statistic for our confidence interval. This is our p hat for our confidence interval. Use a 95% confidence interval, so we are going to write a 95% confidence interval. And in a 95% confidence interval, we are looking for the middle 95% of data, our z-score for this, and we'll talk about probably in the next video how you find that, 1.96 for a 95% confidence interval. And this is something you need to remember. The z-score for a 95% confidence interval is 1.96. All right, so here is what we have to go through. Every single time you write a confidence interval, there are 4 steps. Okay, so 4 steps every single time. We're going to look at this example and another example on the next page. So step 1, we need to talk about what we're doing. So we are trying to estimate p, which in our particular problem is the true proportion of EHS teens with tattoos. Okay, so we always say what we're doing. We're trying to estimate this, p, the true proportion of this, the mean, the true mean of this. Okay, we say what we're trying to estimate. Then we say our best guess is p hat, whatever we got for our sample, right up here, is 0.09, or 18 out of 200. Okay, that's our best guess. But because of sampling variability, we are unlikely correct. Okay, so we just said what we were trying to do. We told them our best guess. Sampling variability is the reason that we're not right, because maybe we got this particular sample, 18 having tattoos, because we just happened to be in a group of kids where they all went and got tattoos. Maybe it's high, maybe it's low. Okay, it's probably sampling variability. Everybody goes out and does a different sample. Everybody's going to get a different answer. Okay, so there's variability in our sampling. So we're unlikely to have captured the exact true proportion in this one sample. So what we're going to do is we're going to give ourselves a range of values around 0.09, above and below 0.09, and we're going to do that using a formula called a confidence interval formula. So now we need to say what we're going to do, what we're trying to do, what we have, and what we're going to do. So we will, I will, you will, we will calculate a 95%. Okay, now we need to say what type. You can't just say 95% confidence interval. We have to say what kind of interval. So this is a Z interval because we're using a Z-score to come up with our standard deviations, our distance away, for what variable, what's our statistic, P. P is what we were trying. So 95%, to name your confidence interval, you say what percent, you say the type. Right now we're just going to have Z. We're going to learn T intervals later for P. It could be mu. All right. So that's always step one. You always write it just like this. So now step two, check the conditions. So our conditions, A, stated as a random sample. Random sample of EHS students. Okay. B, assume 200 is less than 10% of all EHS. Okay, so it's stated as a random sample right there. It says suppose in a random sample. Okay, we assume that 200 is less than 10% of all East High students. It's actually a little bit more. So we might actually, you could be really technical here and say I'm going to proceed with caution. All right, part C, is it a large sample size? So large sample size, remember this is the randomization condition, the independence condition, and large sample size, and for P hat it is N times P is greater than or equal to 10 and N times Q is greater than or equal to 10, and you have to write this and show it. So N was 200 times P, 0.09, which is 18, that's greater than 10, and then 200 times 0.91, which has got to be 182, and those are both greater than 10. So now we can move to step 3. Step 3 is to calculate the confidence interval. Okay, so the calculation of the confidence interval, we write the formula down. Our formula is P hat plus and minus our Z score, Z, they call it Z star, okay, our critical, it's called a critical value. This is called our Z critical value, okay, and in this case it's going to be 1.96, and I'll show you how we get that in another video, okay, times the square root of P hat, Q hat over N. So we write our formula down. From here you could just write down what the confidence interval is, but we're going to do all the steps. So we do the calculations. So now this is P hat, our P hat was 0.09, plus and minus our Z star is 1.96, square root of 0.09 times 0.91 divided by 200. So square root 0.09 times 0.91 divided by 200 is, this is approximately 0.02024. Okay, and if you don't round it, it's even better. So I'm leaving it in the calculator times 1.96. And so I have 0.09 plus and minus 0.0397. Now this interval, this is an interval. We're taking our estimated value from our sample and we're adding 0.0397 and subtracting it. And it's really just easiest if we get these to the same number of decimal places. So really we're just going to take 0.09 plus and minus 0.04. So now we're going to take 0.09 plus 0.04, and that gives us 0.13. And then we're going to take 0.09 minus 0.04, and that gives us 0.05. So our confidence interval, we write it in parentheses. This is interval notation for numbers. This means starting at 0.05 and going up to 0.13 are the numbers that we are going to allow. We are going to allow these numbers, this range of values from 5% to 13%, we're going to say, make our conclusion now. So our conclusion, this is critical. You have to make your conclusion. So your conclusion should say something like, thus, we are 95% confident that the interval from 0.05 to 0.13 captures the true proportion of EHS students with tattoos. So, and we always make our conclusion in a very similar way. Thus, we are 95% confident that the interval, whatever your interval is, so basically you're going to say this exact same thing every time. Change the confidence interval percent if you need to. That the interval from 0.05 to 0.13 captures the true proportion of East High students with tattoos. And that's how you do a confidence interval. So let's turn the page here. All right, so let's take a look at changing confidence level size for just a minute here. I'm going to skip this example. We'll probably do this in another a video if I have a chance, but I thought I'd try to get the changing the confidence level. 95% confidence interval is the most frequently used one. So how would you get, what the confidence levels are? Okay, how would you get that? All right. So if I wanted a 95% confidence interval, which we just got, that means we want the middle 95% of data. Basically in a confidence interval, you've got your statistic right here. And then you're going to allow 2 standard deviations away. So 2 standard deviations away captured 95% of the data. Okay, so how do you know what your critical z-score is? Basically, you need to know what's my z-score right here and right here. This is a positive z-score, this is a negative z-score. So what's the z-score right here? So if this captures 95%, okay, what's left out here? This is 5% out here. Okay, but see, we need to know what number, what is the z-score for down here? That's what we need to know. Okay, but we can't just do inverse norm 0.95. Inverse norm 0.95 is not going to work, because that would mean that 5% is all up here and 95% is down here. But we want the middle 95%. So we just have to think, okay, if this is the middle 95%, I have 5% between each end, which means there's 2.5% here. That's the only side I care about. There's 2.5% here too, but I don't care about that. I care about this, because then that gives me the percent that's below here. If there's 2.5% up here, what percent's down here? 97.5. So for a 95% confidence interval, to get the z-star, I take inverse norm 0.975, because that's the area to the left. So I do that on my calculator. Second distribution, inverse norm 0.975, and I'm doing a z-score, so the mean is 0, the standard deviation is 1, and it gives me 1.9599. Okay, so for a 95% confidence interval, the z-star is 1.96. That's what we round it to. Okay, so now let's say we want to get 90% confidence interval. So a 90% confidence interval, the z-score, well, all you're going to do is say, well, then 90%'s in the middle, so that leaves 10% on either end, so 5% here. So for a 90%, you're going to do inverse norm 0.95, because there's only 5% above that line. Remember, we're trying to capture the middle 90%. So second distribution, 3, 0.950, and then that z-score, that gives you that it is 1.64. Okay, and these are just things you need to memorize. So for a 90% confidence interval, the z-score is 1.64. And then finally, for a 99% confidence interval, you're going to type in inverse norm 0.995. And I'm going to